Hello, very welcome to Biology Lectures with Akerele Olademiji Philip. It's my pleasure to have with me on the lecture. So today I'll be solving this question on inheritance, majorly for KS3. All right, but wherever you are, if it's relevant to you, that it's relevant generally in genetics, but it's for the basics of it anyways. Now it says here the dominant allele big R is used for being able to roll your tongue, and recessive allele small r is used for not being able to roll your tongue. Complete the Punnet Square in the diagram, Punnet Square diagram, to show the cross between a parent with heterozygous RR with a parent with heterozygous RR. So now you meant to just read through those parts, and all of those parts has been represented in this Punnet Square there. So that's our guide already. It's already made simple because normally we're supposed to construct the Punnet Square from the beginning, but this has been done already. So let's work it out. It's going to be big R, big R. I want you to pause the video at this point to attempt it if you've not done this before. If you've seen this as a correction, fine, which means I was going to give you the homework. But if not, you might want to pause the video here and quickly go through this and see how you can do this. Then afterwards to play to see what the answer is going to be. All right. So one big R, one small r, one big R, one small r, then two small r, so to say. So basically speaking here, this person is going to have okay, let me cross the whole thing all the way. Big R, 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 big R. Let me believe that everybody knows what I'm doing, which means this comes down here, this goes in there, so RR, this comes down here, this goes in RR. That's how I've been crossing it. All right, let me get that off so you can look. Small r, since everything there is small r, so it's going to be big R, big R, big R, small r, then big R, then big R, small r, like that. Small r, big R, small r, small r, then big R, small r, big R, small r, big R, small r, big R, small r. Good. Now I haven't done this part. What we need to do is from each Punnet Square, how many of these offspring will be. So let's say from Punnet Square A, I'm actually meant to do something like this. Let me see how I can reduce this for everyone to see together. So for Punnet Square A, like for A, you should talk about how many has RR, how many has. So in Punnet A, we have one child which is homozygous RR. In Punnet, that same, we have one. How many are this? That's what it's saying now. We have two, right? Yes, we have two. How many are small r? So one, we have just one, so to say. Excuse me. Then for Punnet Square B, okay, for B, well, for RR, we have 4. I mean here, every offspring there has the big R, so it's 4. So for big R, small r is nil. For RR is nil. Then for Punnet Square C, how many has? So for big R, small r is nil. For big R, small r is nil. Then for small r is that's homozygous. I mean this one, homozygous recessive, is 4, because all of them has that. All right, hope this is making sense. Then we'll move on to talk about Punnet Square D. In there, it says, so for RR, we have 2. This. For one big R and one small r, we have 2. Then for the small r, we have 0. Then for Punnet Square E, okay, big R, small r, 2 big R, we have 0. For big R, small r, we have 2. For small r, we have 2. Then the last one, which is F. Now we have okay, for the big R, we have 0. For the small r, big R, or big R, small r, we have 4. Yeah, like all of this. Then for the small r, we have 0. All right, hope that this has been helpful. This is the correction. You might want to rewind the video if you have to do that. Thanks for being with me. Please do remember to subscribe and share this to your loved ones and everybody that you think that needs it.